Hello guys, welcome to Tani Tech. In this video you will know that from where for the first time COVID-19 spread, how viruses cause infection, how viruses spread from one person to another, how to prevent from viruses infection, and also I will discuss Sars, one of the type of COVID-19. Let's move towards the video. An outbreak of coronavirus infections in the Wuhan province of China in December is threatening to emerge as the next pandemic. At current count, over cases and deaths have been reported in China and in over cases in other countries. Unofficial modeling studies by a number of institutions claim infections of over 150,000. The alarming speed of transmission is, in part, because the virus spreads through the air and by touch, using the power of medical animation. This video covers what is a pandemic, how this coronavirus is spreading, how coronavirus attacks the body, and what our recommended precautions to take for protecting against epidemics are. Pandemics indicate outbreaks of disease that spread to cover an entire region, or the world. A pandemic can result in massive loss of life. In the last years, there have been 4 global pandemics, the worst, with the influenza pandemic resulting in an estimated 2 million deaths. While no global pandemic has been born from the family of coronavirus, 2 regional epidemics have resulted from this family of viruses. They include severe acute respiratory syndrome or SARS and Middle East respiratory syndrome or MERS into respectively, and resulted in over deaths. Much is yet to be known about the novel coronavirus. An early study of infected showed a high mortality of percent similar to SARS and ICU admission rates of percent. An earlier study described a virus pathology with an 8-day incubation period, a week of infection, followed by a potential escalation to hospitalization and intensive care over another 8 to 10 days. Other indications put the mortality rate closer to 4%. The virus has, as of February, over confirmed cases in China alone, with almost cases in over other countries. However, Dr. Jonathan Reed from the UK believes that the numbers of actual cases is far greater, and has estimated between 2 by February. This is because symptoms can be mild and escape reporting and testing. What's more, in stark contrast to SARS, some patients may be infectious in their incubation period, before the onset of any symptoms. Mechanism of action of coronavirus. The novel coronavirus is a newly discovered strain from the coronavirus family that causes respiratory disease. Humans have long been infected by coronavirus, as it is one of those responsible for the common cold. It is a contagious viral infection, spread through inhalation or ingestion of viral droplets. As a result, coughing, and sneezing, and touching infected surfaces are primary sources of infection. The structure of coronavirus has multiple parts. Inside the virus lies the genetic encoding that allows the virus to hijack human cells and turn them into virus factories. A protein encapsulates the genetic material, known as the viral envelope. On the surface of the virin are SNHE proteins. The structure of the novel coronavirus is a mutation. For more information on this, see the link below. The large S glycoproteins are used by the virus to gain entry to human cells. They most likely attach to angiotensin-converting enzyme receptors on the cell membrane, allowing the virus entry. The exact mechanism for this is not known. Most likely, as shown here, the human cell ingests the virus in a process known as endocytosis. Once inside the cytoplasm, the endosome opens to reveal the virus's genetic material. A single-stranded RNA. The virus hijacks the cell's machinery to replicate the RNA and N proteins, and uses the endoplasmic reticulum to form its M protein outer layer, and the all-important S protein. After replication, the virus is carried by the Golgi bodies out of the cell in a process known as exocytosis so that it can infect other cells. Meanwhile, the stress of viral production on the endoplasmic reticulum eventually leads to apoptosis, or cell death. It should be noted that the mechanism of action for novel coronavirus is unknown. However, scientists in China have sequenced the genome, while others have used the sequencing to visualize the structure. There is currently no cure or vaccine for the novel coronavirus, and treatment is only supportive. Therefore, preventing transmission is paramount. As an airborne virus, recommended precautions are similar to those for preventing the flu. This includes washing hands regularly with soap and water for seconds, covering sneezes and coughs with the inside of the elbow, refraining from touching high-contact surfaces like railings and doorknobs. If you use tissues, throw them away immediately. Avoid close contact with people who are sick. The pandemic risk of the novel coronavirus is very real. However, biology has advanced greatly in the years since Sars, and so has communication between biologists and governments. China has taken monumental efforts to contain the spread of the virus. Also, some existing and experimental drugs are offering hope for treating the infection and improving outcomes. But even still, infection control habits remain paramount if humanity is to stave off a full pandemic. This is SARS-CoV. It belongs to the family of coronaviruses, named for the crown-like spikes on their surfaces. SARS-CoV can cause COVID, a contagious viral infection that attacks primarily your throat and lungs. What actually happens in your body when you contract the coronavirus? What exactly causes your body to develop pneumonia? And how would a vaccine work? The coronavirus must infect living cells in order to reproduce. Let's have a closer look inside. The virus's genetic material contains the information to make more copies of itself. A protein shell provides a hard, protective enclosure for the genetic material as the virus travels between the people it infects. An outer envelope allows the virus to infect cells by merging with the cell's outer membrane. Projecting from the envelope are spikes of protein molecules. Both the typical influenza virus and the new coronavirus use their spikes like a key to get inside a cell in your body, where it takes over the cell's internal machinery, repurposing it to build the components of new viruses. When an infected person talks, coughs, or sneezes, droplets carrying the virus may land in your mouth or nose, and then move into your lungs. Once inside your body, the virus comes in contact with cells in your throat, nose, or lungs. One spike on the virus inserts into a receptor molecule on your healthy cell membrane like a key in a lock. This action allows the virus to get inside your cell. A typical flu virus would travel inside a sac, made from your cell membrane, to your cell's nucleus that houses all its genetic material. The coronavirus, on the other hand, doesn't need to enter the host cell nucleus. It can directly access parts of the host cell called ribosomes. Ribosomes use genetic information from the virus to make viral proteins, such as the spikes on the virus's surface. A packaging structure in your cell then carries the spikes in vesicles, which merge with your cell's outer layer, the cell membrane. All the parts needed to create a new virus gather just beneath your cell's membrane. Then, a new virus begins to bud off from the cell's membrane. Now, with the virus spreading in your body, how can you develop pneumonia symptoms? For this, we'll have to look into your lungs. Each lung has separate sections called lobes. Normally, as you breathe, air moves freely through your trachea or windpipe, then through large tubes called bronchioles, and finally into tiny sacs called alveoli. Your airways and alveoli are flexible and springy. When you breathe in, each air sac inflates like a small balloon, and when you exhale, the sacs deflate. Small blood vessels, called capillaries, surround your alveoli. Oxygen from the air you breathe passes into your capillaries, and then carbon dioxide from your body passes out of your capillaries into your alveoli so that your lungs can get rid of it when you exhale. Your airways catch most germs in the mucus that lines your trachea, bronchi, and bronchioles. In a healthy body, hair-like cilia lining the tubes constantly push the mucus and germs out of your airways, where you might expel them by coughing. Normally, cells of your immune system attack viruses and germs that make it past your mucus and cilia and enter your alveoli. However, if your immune system is weakened, like in the case of a coronavirus infection, the virus can overwhelm your immune cells, and your bronchioles and alveoli become inflamed. As your immune system attacks the multiplying viruses, the inflammation can cause your alveoli to fill with fluid, making it difficult for your body to get the oxygen it needs. You could develop low-lobe pneumonia, where one lobe of your lungs is affected, or you could have bronchopneumonia that affects many areas of both lungs. Pneumonia may cause difficulty breathing, chest pain, coughing, fever and chills, confusion, headache, muscle pain, and fatigue. It can also lead to more serious complications. Respiratory failure occurs when your breathing becomes so difficult that you need a machine called a ventilator to help you breathe. These are the machines that save lives and that medical device companies are currently ramping up production for. Whether you would develop these symptoms depends on a lot of factors, such as your age, and whether you already have an existing condition. While this all sounds scary, the push to develop a coronavirus vaccine is moving at high speed. Studies of other coronaviruses led most researchers to assume that people who have recovered from a SARS-CoV infection could be protected from reinfection for a period of time. But that assumption needs to be backed by empirical evidence, and some studies suggest otherwise. There are several different approaches for a potential vaccine against the coronavirus. The basic idea is you would get a shot that contains faint versions of the virus. The vaccine would expose your body to a version of the virus that is too weak to cause infection, but just strong enough to stimulate an immune response. Within a few weeks, cells in your immune system would make markers, called antibodies, which would be specific for only the coronavirus, or specifically, its spike protein. Antibodies then attach to the virus and prevent it from attaching to your cells. Your immune system then responds to signals from the antibodies by consuming and destroying the clumps of viruses. If you then catch the real virus at a later stage, your body would recognize it and destroy it. In other words, your immune system is now collecting evidence on whether this will be possible, safe, and effective is part of what's taking researchers so long to develop a vaccine. It's a race against time to develop a vaccine amid a pandemic. Each step in vaccine development usually takes months, if not years. An Ebola vaccine broke records by being ready in 5 years. The hope here is to develop one for the new coronavirus in a record-breaking 2 months. While all this will take time, stay home, if you can, to protect the most vulnerable. And don't forget to wash your hands for at least seconds, and as often as possible.